Hello again. In this video, the last in a series of 6, we'll uncover the secrets to selecting the correct answer among a sea of possibilities. Join me as we delve into the strategies, tips and tricks that will lead you through a maze of options before emerging victorious. Here's the first question from the radiation topic. During ionisation, an atom becomes a positive ion. Which of the following has been removed from the atom? To help explain this question, here's a diagram of a neutral atom. It has the same number of positive protons as negative electrons. A passing alpha particle, which is positively charged since it contains 2 protons, as well as 2 neutral neutrons, can attract and remove an outer electron from the neutral atom. Since the atom has lost a negative electron and was electrically neutral before this happened, it must now be positively charged. The answer is B. And in case you didn't know it, the animation showed one way that ionisation can occur. Next up, a question about activity. The half-life of a radioactive source is 64 years. In 2 hours, 1.44 times 10 to the power of 8 radioactive nuclei in a source decay. What's the activity of the source in becquerels? The fact that half-life is mentioned at the start is a little bit off-putting, especially since there's a value given that some people will feel they should use. But to answer this question, we only need the other 2 numbers, as well as this equation. Activity A is equal to the number of nuclei decayed divided by the time taken to decay. Having said that, the time will have to be converted from hours to seconds. That gives us 1.44 times 10 to the power of 8 divided by 2 times 60 times 60, which is 20,000 becquerels. Written in scientific notation, this is 2 times 10 to the power of 4 becquerels, so the answer is A. As I said before, not all the information in a question has to get used. So in questions like this, just make sure you know what's being asked so that you don't get confused. Next up, an actual half-life question. A radioactive source has an initial activity of 200 kilobecquerels. After 12 days, the activity of the source is 25 kilobecquerels. The half-life of the source is... Now here it helps to know that one of the definitions of half-life is the time taken for the activity of the source to halve. It's certainly halved a few times as it decreases from 200 kilobecquerels to 25 kilobecquerels, but how many exactly? To find that, we start with the larger number, then half it. Since we've not reached 25 yet, we'll need to half it again, and one more time. We've got 4 numbers there on the screen, but if you count the arrows, you can see that there are actually 1, 2, 3 half-lives. This all occurred in 12 days, so because 12 days is equal to 3 half-lives, one half-life must be 12 divided by 3, which is 4 days. The answer's B. And so on to the next question. A sample of tissue receives an absorbed dose of 16 micrograys from alpha particles. The radiation weighting factor for alpha particles is 20. The equivalent dose received by the sample is... Now, I always recommend spending time memorising the various quantities and their associated units that go with all the letters and symbols in the relationship sheet. In this topic, pupils often get confused between absorbed dose and equivalent dose. So if you're struggling to memorise some of that information that will help you find the right equation, then search up my video on finding the right equation, which will tell you where you can find a helpful PDF document on my website. The equation we want here is this one. H is equivalent dose in sieverts, D is absorbed dose in grays, or joules per kilogram, and WR is the radiation weighting factor, which you can also find in the datasheet at the start of the exam paper, although you don't need to in this question. Different types of radiation have different values of radiation weighting factor, and it's just a number. In other words, it doesn't have any units. Substituting our values into the equation and remembering that 16 micrograys is 16 times 10 to the negative 6 grays, we get 16 times 10 to the negative 6 times 20, which is 0.00032 sieverts. This is equivalent to 320 microsieverts, so the answer is E. Up next is another one of those questions where we have to work out which of a student's statements are correct. A sample of tissue is irradiated using a radioactive source. A student makes the following statements. The equivalent dose received by the tissue is 1. Reduced by shielding the tissue with a lead screen. 2. Increased as the distance from the source to the tissue is increased. And 3. Increased by increasing the time of exposure of the tissue to the radiation. Which of the statements is or are correct? So remember that equivalent dose is a measure of the biological effect of radiation due to factors like the type of radiation, absorbed dose, type of body tissue exposed, and so on. It's pretty straightforward that shielding the tissue with a lead screen will reduce the biological effect of the radiation. So the first statement's true. If we increase the distance from the source to the tissue, then surely the biological effect would be reduced rather than increased. Statement 2 is false. Finally, increasing the time of exposure of the tissue to the radiation will of course increase the biological effect, so the last statement must be true, making the answer E. In summary, equivalent dose is reduced by using shielding between the source and the tissue, increasing the distance from the source, and minimising the time of exposure to the radiation. So if you enjoyed this video and found that it's helped in your understanding of physics, then why not subscribe to the channel so that I can eventually get a play button up on my wall. Dropping a like on it wouldn't hurt either.